Hello everyone, this is going to be a short video about I/O view and SFRs windows, so let's get started. These two windows are used to view the SFR separately during debugging. Again, SFR stands for Special Function Register, and they are the registers you use to configure your microcontroller, like the OSC-CON and OSC-TUNE registers here. In the previous video, I talked about how you can use the Watch As window to view your SFRs, which also shows the bit groups. You can do that because SFRs also reside in RAM and can be read by MPLAB like you would a variable. But these two windows are specialized for viewing SFRs in particular, and the I/O view window is more graphical too. Since we're gonna view SFRs, let me create a simple example that focuses around one. I'll configure the pins from RB0 to RB4 as outputs, since they're physically right next to each other, and their related bits reside in the same SFR, which will make it easy to see what's happening. And I'll go ahead and write some code that updates the lat bits of these pins each second. Now, can you understand what this code does? Here's my microcontroller, and I've gone ahead and connected 5 LEDs to these pins so we can see their status. Let's program and see what happens. As you can see, the first LED lights up and shifts to the left each second, and it wraps back around at the end. Simple, right? Here, I have a pin value variable, and each second, I extract the bits 0 to 4 from this value and use it to update the lat bits. I initialize the pin value as 1, which is why the first LED turns on initially, and here, I'm shifting that value to the left, which is why the LED shifts. And here, if the value becomes 32, I reset it back to 1, which causes the wraparound. Now, we can use this example to see how the SFRs change, and you can find the download link for the files in the description below. Before we start, I'll place a NOP instruction here right after updating the lat bits, and place a breakpoint on it so we can view the SFRs right after updating the pins. And let's start debugging. Now, let's open these windows and inspect these SFRs we're configuring. I'll first show the SFRs window since it's simpler. As with every other window, go to Window tab first, navigate to Target Memory Views, and click SFRs. This window shows you all of the available SFRs for your microcontroller and displays the values they contain in various representations. You can also choose the peripherals format here, which will organize every SFR under the respective peripheral they configure. Again, like in the previous video, the red values are the values that changed since the previous halt, and you can overwrite them by double-clicking them and writing your own value. When you're in the peripherals format, you have the option to filter the peripherals using this button. Let's select the port B related registers here. And here's the lat B register. Now, lat registers don't have initial states, so ignore the bits 5, 6, and 7 as they won't necessarily be 0. And as you can see, the value corresponds to the LEDs that are lit up. And if I rerun and halt after another loop, you can see how the SFR updates and matches with the lit up LEDs again. And I can overwrite this value to say all ones. And all of the LEDs turned on too. And if you ever want to remove the register filter, you can press this button. The I/O view window is essentially the same as the SFRs window, but more graphical. First, let's start a new debug session. To open it, go to Window tab, navigate to Debugging, and click I/O view. Here, this top part is for filtering the peripherals, just like in the SFRs window. And this bottom part is for the registers. If it's taking up too much space, you can toggle both of them using these two buttons. And the same filtering buttons from the SFRs window are here, though you don't really need them because of this tab. Now, let's choose the port B related registers again. The way things are shown may seem complicated at first, but it's very simple. Each one of these squares represent a single bit, hence there's 8 of them per row. The white ones are unimplemented bits, which you can also see from the datasheet. They're grayed out and marked as unimplemented. The blue and red ones are bits that are set or 1, and the empty ones are bits that are cleared or 0. The red ones are the ones that you overwrote, or ones that changed since the last halt. And the numbers on the bits just show you which bit they are, so bit 0 to bit 7 here, for example. You can also click the arrows on the left to expand these bits on individual rows, and each row will show every other bit as unimplemented. Simple, right? And the same way, we can rerun and halt after looping to see how these values update and match the LEDs on our microcontroller. And also, the same way, you can overwrite these values by double-clicking and entering your own value. And you can see how the LEDs also changed accordingly. You can also directly click on these squares to toggle them. And as you can see, they reflect on the LEDs in real time too. You can use this button to make it so the changed bits don't show up as red, but instead show as normal color. And you can use this button to open up this tab, where you can individually modify the colors. And this last button searches official online documents for some of the microcontrollers using the selected register as the keyword. I don't really know what this search would be for, but that's how it is. And that's the end of the video, and thank you for watching. If you liked the video, you can always leave a like and subscribe. It's always appreciated. And I'll see you in the next video.